Hi there. Section 11.3 is on contingency tables, which are basically matrices. So we're going to test the claim that two variables are independent. Here's a quick example. The way that a person votes is that independent of their gender. So with gender, there's only two categories, male and female. So there's no numerical data. You can't say gender is 7.3, 8.6, 5. So consequently, we can't use linear correlation, which was another way that we compared two variables. So we're going to organize the data in a contingency table. And here's an example. And I just made the numbers up for this. Would you vote for Hillary Clinton? And let's say out of 120 men, 45 said yes. Out of 150 women, 80 of them said yes. Okay, here's the same data, and I'm going to organize it in a table, a contingency table. So the categories on one side are the gender, so men and women, and then whether they said yes or no. And for the men, it was 45 yes, so if you subtract from 120, you would find out that leaves 75 for no. And for women, it was 80 that said yes, and if you subtract from the 150, that would be 70 that said no. In order to use in order to find the test statistic, we're going to use the calculator. And this is something that we haven't done before. We're going to use a matrix. If you look down here in the very lower left-hand corner in blue, it says matrix. So I had to go to second matrix. This is the first screen. Then move over to edit and hit enter. And if you haven't used this before, you would need to type in this is a 2 by 2, which means it has 2 rows and 2 columns. And if you haven't used the calculator before for this, then what it'll do is it'll put zeros in here, and you just have to type in the numbers 45 enter, 75 enter, 80 enter, 70 enter. Okay, that's done. Then get out of the matrix, so put second quit, and go back to stat, move over to tests, and look for chi-squared test. All right, when you do that and hit enter, then it should look like this. So the observed values, which are these values right here that we observed, are in matrix A, and the calculator is going to put the expected values in matrix B. The idea with the expected values, and sort of the idea of this whole thing, is we are trying to say that gender has nothing to do with whether the person said yes or no. If that's true, these numbers should have been split evenly. So in theory, these wouldn't be lopsided, they would be evenly split. Like with the women, it's almost evenly split. With the men, it's not evenly split. So most likely there is some gender bias or whatever you want to call it. There is some effect between gender and whether or not they would vote for Hillary Clinton. Okay, then on to actually right here in this black bar, the calculator was flashing calculate, so hit enter right there, and then it'll tell you the test statistic, 6.722, and also degrees of freedom. For chi-squared, that's table A4, and go ahead and use degrees of freedom, 0.05 for right tail. These are right tail only tests, so whatever the alpha is, that goes in the right tail. And if you look up table A4, you'll find the critical value 3.841. And then just write down the test statistic, which is 6.7. That definitely goes past the critical value, and so we did prove something. So the claim of independence is rejected, or in other words, they're not independent. That then means they are dependent. So somebody's gender is dependent on how they vote, or how they vote is dependent on their gender. And as you can see, there's a higher percentage of women that would vote for Hillary Clinton compared to men. Keep in mind that I just made up those numbers. Next example. So with this one, the data was just given as a little list right here, but with the next example, we're going to test the claim of independence between gender and then the balance on a Visa card. So with balance on a Visa card, you can have all kinds of numbers, 235, 122, etc., etc. Okay, so first of all, you need to count how many men are there and how many women are there. And this one is split right here, so that's going to be easy. Just count how many men, how many women. And then you need to divide this data sort of in the middle. So what I'm going to do is use the median. So I typed all of these into a calculator. I found the median. It was 624. So you don't have to use exactly 624. I'm actually going to use 625. It's a little bit easier for me to remember, 625 for some reason. So everybody with a balance under 625, I'm going to count them. So I'll just go through and put a little check mark by everybody that has under 625. And that would look like this. So I counted, there's 19 men, 16 women, and then I just put a check mark if they had a balance less than 625. Okay, and I counted, there was 9 of the men that were under 625 and 9 of the women were under 625. So next we need to make the contingency table or the matrix. So here's the categories under 625 or over 625 compared to their gender. And it's like this, there is 9 men under 625 and 9 women under 625. And then if you just count the ones that don't have check marks, you would get this 10 and 7. So that makes the contingency table. And use the calculator to find the test statistic. So this is the same as I just did. We're going to go to matrix. So put second matrix, move over to edit, type in the numbers 9, 10, 9, 7. And then again, go to stat, move over to tests, and go to the chi-squared test. It's going to, this part should always just say observe matrix A, expected matrix B, and then calculate. And the test statistic is very small, 0.274. Degrees of freedom is 1, that means the critical value is the same as last time, 3.841. And if you write down the test statistic, you'll see that it lands way over to the left, not even close to the critical value, so that's going to be fail to reject. So that's basically saying that no, we didn't find a major difference between men and women when it comes to balance on their Visa card. Everybody's in debt. Okay, so that's section 11.3.